Hi, I'm Bryan Acosta, and I'm going to be doing question 8.
All right, question 8. What are the densities of the following gases at STP? So, the first part of the question, part A, says we're looking at CF2Cl2 at STP. So when I look at this question, I identify a few things you're probably going to need to understand or know beforehand. So at STP, there's a lot of different variables that are very set at STP. So for 1 mole of gas at STP, we're exactly 2.4 liters. And I put a little bit of simple equations just to show this, how it works. But pretty much, yeah, at STP, you have different requirements. So you're at 1 ATM, and this is our constant right here, and you're at exactly 0 degrees Celsius or 273.15 degrees Kelvin, which if you plug in 1 mole, shows you exactly what I just mentioned right here. So hopefully that helped you understand if you're a little bit confused about that. So the question itself is asking for density. So density is regarded as mass over volume. In this case, it did not tell us exactly what our units for density is, but I assume it's going to be grams over liters. It could be grams over milliliters. You just got to pay attention to the question. So for CF2Cl2, our molar mass is 120.9 grams per mole. The way I got this is the molar mass on the periodic table shows for every single element, and you're just going to have to multiply that for 2, since this is, it's not diatomic, but it shows a subscript of 2. And for chloride as well, there's a subscript of 2. So just after adding all those up, you should get the grams per mole. Now, density itself, since you can see the molar mass is grams per mole, it would really benefit us to do 1 mole of gas, to look at 1 mole of gas, because we already know the value of volume for 1 mole of gas. So just imagine you're plugging in a 1 here, and then you'd be looking at 120.9 grams per 1 mole, just plug it in this equation, and that way you can use this liters value, and you can just simply solve for your density. So it turns out to be 5.397 grams per liters. All right, and that'll be part 1. All right, part B. Now part B, we're looking at CO2 at 800 torr and 25 degrees Celsius. Now the question specifically asks is for the following gases at STP, but I kind of noticed that perhaps this is a little bit different, and if I covered the first section, part A, then you'd be able to understand how to do it for part B. So I decided I might as well go over what is exactly written on the question, which is this for part B. So in this case, we're actually not at STP, and right here I put the derivation so basically density is still mass over volume, of course, but since we're not at STP, we're going to have to derive another formula for this. We did do this in class, but I might put a little subscript number at the bottom of this video, so you can skip to the part where I skip over this derivation process if you already recognize the formula. But if not, I'm just going to go straight into it, and hopefully you guys all understand. I'm going to try to explain it as best as I can. So using our basic PV equals nRT formula for ideal gas law right here, N, or the number of moles, can be described as the molar mass, or mass in grams over molar mass. And you're probably thinking like, what and why? Where'd you get that or something? But if you actually look at the units for each of them, gram over gram per mole, using some simple algebra skills right here, it actually cancels out and you get moles. So yes, it's the same thing. We're just writing it in different terms. So after plugging that in, you can see we just plug it in here, and we do some basic recalculating. We multiply by m on both sides to get rid of the m on the bottom, and we redistribute RT over to this side. Let's see. We redistribute V over to this side, and then let's see here. We pull out the M and the V, and we're left with this, okay, MV. And as you see right here, as I have listed, density equals mass over volume. This is exactly mass over volume, so therefore it is density. And we go ahead and we solve for density. So yeah. So now that I've established this new formula on how to solve without the STP, we're just gonna go ahead and look at what we have. So CO2 is 44.01 grams per mole. That's the molar mass of CO2. If you don't know how to find that, if you look at your periodic table right here, it's carbon dioxide. So carbon is 12.01, oxygen is 16. Since we have 1 carbon and 2 oxygen, it's simply going to be 12.01 plus 2 times 16. And that should give you our molar mass of 44.01 grams. All right, so now that we have everything, we can simply use this formula right here and plug it in with everything we know. So torr is technically, in our class, we use this constant 0.08206 because it is in terms of liters per ATM per Kelvin. But this question has torr. So just to make life a lot easier on us, we're going to convert everything to what we normally use and then solve for density. So this is grams per mole, that's perfectly fine. For this 800 torr, we're going to go ahead and make it into ATM. And then this degrees Celsius, you should always convert to Kelvin when dealing with ideal gas. So after plugging everything in and then just doing some simple algebra and solving, you get a density of 1.893 grams per liter.